Hi everyone, I'm Sammy from Avid CNC. Thanks so much for joining us today. I'm really excited for this project and for this workflow I'm going to show you. If you have any questions, as usual, please feel free to drop that in the chat or in the comments below. I'm excited to show you this project because it's kind of something I've been bouncing around in my head for a little while, and I've thought about lots of different ways to make this particular project. And this process that I'm going to show you seems to be the most versatile and accessible process for most people. You can use any kind of digital fabrication tool that you're using, whether it's a CNC, a plasma CNC, a laser cutter. You can even cut out a PDF template if you like. Today I'm going to use my plasma CNC to make this project. So I'm excited to show you. So I'm going to show you several different CAD/CAM programs, and that will include Fusion 360, Slicer for Fusion 360, which is the really key program I want to focus in on today. So Slicer, I will explain a little bit more about that in a minute. Also, I'm going to be using Vcarve Pro Sheet Cam as well for planning my toolpaths, and also Mach 4 as a controller program. So I'm going to be using Fusion 360 to create my initial model and overall body of the design. Fusion 360 is not necessary for this particular process. You can download a file from Thingiverse or wherever you like. An STL file is really all you need. And then I'm going to demonstrate what's called Slicer for Fusion 360. This was originally created by Autodesk for 123D Make. And many elements from this era of Autodesk's kind of design tools have been integrated into other aspects of Fusion now. So this is a really great kind of add-on. It's free, it's a standalone program. You can export your file from Fusion directly into Slicer, or you can just upload an STL file. So that's really nice because it's super accessible and available for anyone. I did try it on the Mac and found a few bugs, so I'd recommend using it on Windows, but it really ultimately works on both. You can get results either way. It's just the navigation is a little bit tricky on Mac. So everyone, please let me know where you're tuning in from, and I'm excited to get to, that you all are here and to share this project with you. Okay, who do we have? We got folks from, Brooklyn Navy Yard, cool. Charles, hi. Old and Wise, Dave, Simon, Mark. Thanks everyone for coming. Appreciate you being here. We got someone from England. Wow, we have to have our international representation, so thank you so much. Okay, so I'm also going to demonstrate nesting and laying out my parts in Vcarve. That just happens to be the vector program that I'm most comfortable with. You can also use LibreCAD, which is a free program, and that just kind of helps me lay out the parts. You can make your toolpaths in whatever program makes sense for you. I'm going to be using SheetCam because I'm making it out of metal, and you can use Vcarve if you're going to make it out of plywood or a plastic and that sort of thing. Awesome. So today I'm showing you, okay, you probably have seen over here, I have my Wormhole geometry inspired side table. Obviously you don't have to make this, but this process should help inform if you're making furniture, architectural installations, all sorts of things, sculptures. So this is kind of what I would call, it's an interlocking radial assembly. So I'll show you kind of the inspiration where I started from. So here I'm going to switch over to I can get my mouse over there. Okay, so here I have my this is where I started with the inspiration, and it's the black hole, well, technically not a black hole, it's a wormhole geometry. And this is really what I wanted to be inspired by and what I was bringing to my design elements. So I don't think I struck this just perfectly. I think I'm going to do a couple more iterations of this project, but the process is really interesting, and I will try to finish the metal to look kind of like this. So I think I'll clean it up, paint it white, and then paint just the edges black to kind of reiterate this kind of black and white illustration aspect, which I was really drawn to. So, okay, I'm gonna try to pay attention over here to the chat, and I'll answer your questions as we're going. We also have Eric, one of our founders, who's helping monitor the chat today, so thanks for helping with that. Someone's teasing me about my clean spoil board. Believe me, it is been cut into, but I've recently, there are different reasons to zero to your material or your spoil board. I've been trying to zero more to the spoil board so I don't cut into it as much and like have it last longer. So that's kind of my priority. When you have a shared tool in a makerspace, you don't get to treat your spoil board the way you would always. So you have your own options to kind of have it be the way you want it to be. So I try to keep it clean and exactly how I want to have it set up all the time. Okay, so I'm going to go ahead and show you how to model something very basic in Fusion 360. And then I am going to show you Slicer. So I did a couple iterations of very simple models here. I have kind of a square shape. So you can kind of see in the geometry here, the cross sections are circular, but the top and bottom are square. So I didn't quite hit that just perfectly, so I'm going to do a couple more iterations of that. But this kind of gives me the general idea. So I made a square one and a round one as well. I kind of ended up liking the visuals of this better. So we'll go ahead and do that. I'm going to start a new design. Go ahead and click plus, add new design. So when we make a new design, first thing we want to do is to save. Okay, so I'm going to say black hole, no, wormhole. My friends were saved me from some online embarrassment calling it a black hole. Thank you, Winston and Alice, for saving me there. Wormhole live stream. Okay, so I'm going to go ahead and start with creating a sketch, and I'm going to select this plane here, and I'm just going to remind you about one of my favorite aspects of Fusion is the parametric. Oh, why is this? Of course, it's popping up down here on my other monitor. So, okay, well, so we can skip the parametric for right now because it doesn't want to come onto my monitor. So here I'm going to just create a circle, just say, I don't know, maybe 6 inches in diameter, and click enter. Perfect. So I'll say, finish this sketch. Now I'm going to create a construction offset plane. So I'm going to select my original plane and then bring this up to half the height of my overall table. So say I want it to be 18 inches tall, I'll make it 9 inches offset. So now I'm going to create a sketch on the offset plane. So I'm looking at it from above, but I'm drawing 9 inches above my origin. So I'm going to go ahead and, should we do a square or should we do a circle? Let's do the square. Okay, do the rectangle. I'm going to select the center rectangle so then it can start in the middle and then pull out. Okay, so I'm going to type in my dimensions. I'm going to do 18 by 18 inches and then hit enter. So if I look at it in 3 dimensions here, I'm going to hit finish that sketch. I have my rectangle or my square and my circle, and that's it, right? So now I'm going to go ahead and loft my 2 shapes. Let's go to modify. Oh, no, we're going to create loft. So what I'm going to do is I'm going to select both my profiles here. You see it automatically connects them. So I have a couple options here and I can kind of play around with these. I'm going to go ahead and click direction on the bottom one. You can kind of see how it changes the shape of it. This one, if I change this, it'll make it kind of like an hourglass shape. I'm just going to select connected versus direction and click OK. So that's the top half of my table. So now I'm going to go ahead and find mirror. Where is it? Yeah, mirror. I'm going to select my bodies, select the body I want to mirror. The object is selected, and then select my mirror plane. So I'm going to select the bottom here, and now it should just mirror the object. So now I have my overall shape. I feel like pretty good about that. Looks good. Now I'm going to go ahead and throw some fillets on here, on these edges. Just, oh, you know what, actually, before I do that, I'm going to take my bodies and I'm going to combine them and just join those together. So now I have one body. We'll go ahead and give these a soft fillet, just so I don't have a square edge there. I don't know, let's see, let's do like 2 inches maybe. There we go. So this one's kind of nice, and that gives me the concept and the kind of the visual representation of the overall shape I'm trying to accomplish. So now I can go ahead and just, you know, I can export this. Let's see, how do I do? Okay, so now I need to get this into Slicer over here. So if I open Slicer, I can now import my model that I want. Where'd it go? Okay, 1 second. I'm just gonna go ahead and export this. See if I remember how to do that. I've done this a bunch of times. Okay, I'm just gonna switch over to this camera really quick and go ahead and keep throwing those questions over here. I'm happy to keep answering them as I just get my file set up really quick. Oh yeah, okay, so I'm gonna switch back over here. I just, screen share, I'm gonna go ahead and select save it as an STL. So I'm just gonna save it to the desktop. You can use the Fusion plugin to transfer it over directly, but I found that this kind of works better, and this is kind of how I would do it. You know, if you're not getting Slicer to connect to Fusion perfectly. So we'll go ahead and say, we're gonna save that out. I'm just gonna save it to the desktop. My keyboard takes a second to connect over here. Black hole. No, wormhole. Wormhole STL. So we're gonna save that. Now I'm gonna close this and go into Slicer. So you can, I'm gonna show you really quick on Google here. This is where you can download Slicer. I put a link in the description below. And this is where you download it for Mac or for Windows. And it is a standalone program, so you can import an STL file and then use this independent of Fusion. But it's nice that it's been created kind of outside of that realm, but works really well with your Fusion workflow as well. So here in Slicer, I'm going to go ahead and import my model. I'm going to go to my desktop and get my wormhole file. And so now I have it imported. So you'll notice here that the Y is up in Slicer, and that's unfortunately not something you can change. I should have in Fusion changed my Y to be up, and it would have imported the model, you know, the way that I wanted it to. See if I can, I'm switching back between commands here. Oh yeah, okay, so right click is rotate and the wheel is pan. Awesome. So now I'm going to go ahead and show you the different processes within Slicer. So in manufacturing settings, I can click on this edit icon and it brings up my material library. So I can add in my own materials. So you can see down here that I've already made 16 gauge steel. So let's go ahead and make an example just so I can show you. So we're going to call this 1/2 inch plywood. So this is just an example of, if you're wanting to make this out of plywood or acrylic, something like that. Let's say our material is 48 by, 96 inches, and say thickness is 0.5 inches. I'm just going to set the margins. Oh, so the margins, the horizontal and vertical margins, are the spacing between your parts or between the edges. So we'll just leave that there. I'm going to leave no tool offset for now, but you do want to enter in your tool diameter. Okay, so we'll say done. Okay, so now I have imported my model and it seems to have changed my dimensions. I also want to make sure to scroll down here and select the material that I want to use. Hey Olivier, thanks for joining. Okay, awesome. I'm glad you're here. Olivier, if you guys haven't seen, he has his CNC set up. I'm really excited to see all the things that he makes and how it gets integrated into his space. Okay, so yeah, so Steven has some good points. Using parameters makes this a lot easier. Yes, I was using parameters, but because my screen set up, my stream, the pop-up wouldn't allow me to move it around. So I will show that more next time. Definitely, I love using parameters in Fusion 360, so I highly recommend learning that aspect if you haven't already. Okay, great. So here I'm going to go ahead and adjust the object size because it didn't import at the exact one that I wanted. I want to keep it uniform, so if I adjust one dimension, it adjusts all of them, X, Y, and Z. And so now we're going to select a construction technique. So this is why this is one of the most versatile types of construction software programs that you can use. It gives you lots of different options and translates really well to CNC fabrication. So we can do a stacked slices here, or you can do interlocking slices. I call this kind of a waffle structure, but I'm sure there's lots of different names for it. We can also do a curve. So those interlocking slices, you can adjust to be on a curve and not just, perfectly perpendicular. We can also do radial slices, which is what we're going to do for this project. You can also do folded panels, this is another one of my favorite techniques. So if you're interested in the future, perhaps I'll do this with a drag knife or cardboard cutout on the machine, because I love doing those kind of folded geometric low poly sculptures. It can also be used for things like an Iron Man mask. That type of thing is what this is really popular for. You can also do 3D slices. I see, yeah. So we're going to go ahead and go to radial slices. So this is where I'm going to start. So you can do several different things with the slice distribution. You can do it by the count or by distance, and it'll calculate that for you. I'm just going to do by count, so it's evenly distributed over the dimensions. And here we can change our slice direction. So I'm going to go ahead and select this and move my radial around to the vertical of it because I want the stripes to be going up and down. So I'm going to rotate that this way. See? Yeah. Okay. So I guess I'll put it this way so you can see better. And I'll zoom. Does that help? Okay. And I can also rotate on this direction as well. Got my little handles here, but I really wanted my corners to be lining up here. So what I ended up doing was on my radial count, I made this 12 instead of 10 because I wanted the 4 to be on the corners, and it would just be a lot easier to fabricate them later on. So that's pretty much it for this aspect of it. It's very simple process for using Slicer. So hopefully this helps inspire you to use this in different projects. So you can change the slice direction. I also want to say thank you to Paul from Fusion. If you have not seen his live streams on the Fusion Instagram 3 times a week, I believe, Monday, Wednesday, Friday mornings at 9 a.m. You should check that out. He helped, gave me a little walkthrough for Slicer, just so I want to make sure I didn't miss anything showing you today. He recommends skipping modify form. There's a lot of other programs that are better at modifying the model than Slicer, so you can skip that. Another really awesome aspect of Slicer is the assembly step. So it shows you what the best order of fabrication is. I'm going to go through and show you something, finish with Slicer, but I did forget to show you one thing that I did in Fusion, because you can see this is solid in the middle, and I want it to be hollow. So I will go back and show you that in a second. So we have the assembly steps. I can see it in cardboard, in plywood, in plastic. Actually, I kind of like this solid too. It's cool. I can rewind and play it so it can show me how to assemble this correctly in the right steps so that it will actually come together. So this is a nice thing. It gives you a guide on how to assemble it and what order to do that in. Yeah, that looks really neat. I feel like this could be used really well for a bookcase and that sort of thing. So the assembly steps are a really handy tool that this offers you. Now we're going to go to Get Plans here, and it's already laid out my parts for me on my sheet. You can see here it's not nested as well as if I had nested them, so I do prefer to take that into Vcarve and do the layout myself, or whatever kind of vector program that you want to use. You can also import them back into Fusion, but it does export it as a DXF file. So down here I can say file type DXF, export to my computer, and I'll just save that, you know, my Wormhole vectors, and save to my desktop. You can also save it as a PDF if you would like to print it out and do it by hand. Obviously, I'd prefer using a CNC machine or a laser, so that's what I ended up doing. So really quick, I'm going to go back into Fusion and show you one step I skipped. So if I select my body and I go to Shell, I can select my 2 faces here and decide what my thickness is. I'm going to do 1/2 inch, and the direction is inside. Now I have the shell of the form that I want. So if I go ahead and save this as STL, we'll call this Wormhole shell. If I import that into here, you can see how that changes it. So that's kind of closer to what I have fabricated over here. So that's don't skip the shell shape if you want, or the shell step if you want to make it more hollow. Okay, awesome. So now I'm just going to go ahead and nest my parts here. I'm going to open Vcarve. It's my preferred one, whatever kind of you know, CAD vector design program you want. So I was cutting this out of steel, so I have 4x2 foot sheets of 10 gauge steel that I'm using. So that's, I just like to use those XY dimensions here so I know it's going to fit on my material. But the Z thickness and the machine bed doesn't matter, or the zeroing point, because I will do that in SheetCam. I'm going to file import. Oh, you know, I didn't export my this one. So we'll go ahead and get plans. Oh, it's interesting. It puts it all in different. Okay. I'm going to do this on my 10 gauge steel. Okay, so now I'm going to go ahead and get my plans, export to my computer, Wormhole, shell, DXF. Perfect. So now in Vcarve, I'm going to import that. Vectors, Wormhole shell, and open. So one really other great thing that Slicer does is that it gives you annotations. So if you're going to make this out of wood, I would recommend on here it's put your different vectors on layers. So here it's got annotations where it has the numbers of the parts and shows you how those come together. Because mine was mostly symmetrical, I didn't really label the parts with the plasma cutter because that's not its strong suit. But if you're going to be laser cutting or machining this on your router setup, definitely use a V-bit, throw that in there, do an on-the-line profile pass. That'll be really great. So I'm going to turn off annotation actually, and then just use my boundary, and it puts the boundary and the whole, the insides of the parts on another layer. So if that's something that's important to your process, that's fine. But I'm going to go ahead and move these to the same layer as boundary. So I'm going to hide that, all the other layers that I have. And so I'm just going to go ahead and I'll even group these just to make my life a little bit easier. And I can just go ahead, I can hand nest this, I can try to nest it using the nest feature, but this doesn't take too long, so I just kind of organize this the way, you know, if you're working pretty quick, that's fine. So here I don't have too many parts, so I'm going to go ahead and put those on here, and then we'll go ahead and jump into some sheet cam, and I'll walk you through the plasma CNC process. So if you're interested in more plasma CNC, I've also, I believe, linked in the description below the plasma CNC live stream from a few weeks ago. Please go ahead and give that a watch if you're interested in doing that. I feel like this project is, you know, a good one for that. And I'll explain some of the kind of tricky things I had to work around. So I can lay out these parts however is best nesting on here. Okay. So I'll just show you an example. Okay, so I have my parts and they fit on my sheet. Obviously you want to nest them closer together. You know, if you're dealing with tabs and that sort of thing, you can just go directly into toolpaths over here and make your profile toolpaths if you're going to be doing it on your router. But for sheet cam, I'm just going to select these. I know that there's some more over here, but I'm going to just go ahead and jump forward. We'll select these vectors and file, export, DXF. We'll say this is Wormhole shell nested. Okay, so now I have that DXF saved. So I'm going to switch over to a video that I'm going to do some voiceover, and I can show you the whole machine setup process. If you want to learn more about plasma, check the description below for that full walkthrough, but this should give you the general idea. So I'm going to go ahead and open, we're doing 30 minutes, pretty good. So we're just going to go ahead into directly into sheet cam. So here I am opening sheet cam, and I'm going to import my vectors. So I'll go to new part and hit yes, and select the vectors that I want to open. So be sure to import it in inches, and you can see I have my parts in there. The red space behind is just the job setup. It shouldn't affect anything. I'm I'm going to make my first toolpath. I'm going to make a test initially to make sure my parts fit together. And I'm just going through the steps to create my toolpath. So I'll select an outside offset, and with my material selection, I'll make sure I'll select the 10 gauge, which has the proper settings. And I can move my start point around to wherever I would like. And we'll go ahead and make our toolpath for the remaining parts as well. So I'll go through the same setup, outside offset, and select the layer for boundary. So here I really like to be thoughtful about where my start points are and go ahead and place those. So we have a question about how do you control the height or liftoff between two cuts on SheetCam, Aspire, or Mock? So for Vcarve, we can set a safe Z height, and I'll show you how to do that in a little bit. So here in this clip, I am adjusting the job size. It's just kind of visual representation. That's not going to affect your toolpath when you post it. So here I'm going to go ahead and post my G-code for the test first, and then I'm going to post the final toolpath just in case that my test worked out well. So the first thing I'm going to do when I turn on my machine is I'm going to make sure that the controller is communicating, and then I'm going to home the machine. Awesome. Thanks everyone who's been joining us. We're just going through the steps of actually fabricating these parts. So we're going to home the machine, and we're going to get our materials set up and show you how to load your code and cut the parts. Plasma CNC is one of my favorite tools. I love the instant gratification. It's got fire and sparks, and you know, it's a really fast process to iterate on different things. So here I'm going to go ahead and move the machine slightly out of the way, just using my jog keys on the keyboard. And then I will go ahead and make sure to get my material just set onto the bed evenly. I know I need to empty my water table, but maybe this weekend. Okay, so you get the material on the bed. It's a pretty hefty piece of material, so I don't have to worry too much about it moving around. Don't forget to attach your ground clamp. And then I'll drive my torch head over to about 1/2 inch inset from the front and left corner of the material. And then I can just manually click 0x and 0y. And the Z will zero itself with touch off. Awesome. So don't forget to turn on your torch and make sure the air compressor is all hooked up and everything. I'll load my G-code, and we'll go ahead and make sure you wear your safety glasses and run our first test. So it's just such a fast process of iterating. You know, you don't have to worry about tabs and woodworking. The one difficulty I did run into with using Plasma CNC for this process was not the kerf angle of the part. So the cuts were slightly beveled, which made it difficult to slot them together, but I did manage to get the part come together. And here I've just kind of left up the preview on the right side so you can kind of see the machine moving in the same way as the preview, the visual preview up in the right-hand corner. Some good questions here. How careful do you need to be with electronics around the plasma cutter? when someone used one in our hackerspace, Arduinos nearby went haywire. Yes, this is metalworking is a really messy process. And if you don't want to get dust or water or dirt on things, definitely be careful of things around it. I will say that our electronics are kind of designed to be in this environment. So do be careful of what you put around it. But it shouldn't be an issue for the setup that we have. Why does the start position matter when planning for G-code? That's a really good question. So this is a zeroing question. Why do we need to be really sure about the start position? So that's why we home the machine at the very beginning when we turn on our machine. That the machine I like to think about it as waking up, and it kind of is like, where am I in space, and reaches out and is kind of like trying to get its bearings. And then you need to give it a start position, like on a map. So if you're trying to find treasure on a map, you don't necessarily, you're not going to get to where you want to go unless you start at the same point as the map tells you to. Here I am just removing the parts from the material here. Do be careful, it can be hot, but the water does splash up and kind of help with that cooling. Now I'm going to go ahead and clean up my parts and show you the assembly process. So this is the fun part, or the not so fun part, depending on how much you like using an angle grinder. Luckily they didn't slide around too much. I did have some slag issues, but you know, new consumables certainly help with that. Okay, so you mean per piece. So start position matter per piece. Can you clarify that question for me? I would love to help answer that. So here's me assembling the part. This was definitely difficult to do by myself, but I did manage to get it to come together. It slotted together pretty well. I think that there was some variation in each arced piece just because of how I had set up the slices. And, you know, thanks so much for watching that with me. I thought this was a really fun process, and was something that y'all could use in lots of different ways in different processes. So if you have any more questions, please throw them in the chat and I will try to answer them for you now. So, okay, so you're setting the start position per part. Oh, I see. Okay, per part. Let me go ahead and show you. Do I have sheet cam set up on this computer? Let me see. Okay, so I don't have sheet cam set up on this particular computer, but let me tell you about why the start position matters for each element. I opted to do an arc lead in and lead out, and this is because of when the torch enters the material, it has to pierce. So it kind of has to give it a bigger blast, which puts a kind of a dot on the end of your cut. And you don't want that to be right on the edge of your piece. So having the lead in, lead out helps with that. And then you can also kind of dictate where you want the start point to be, because you don't necessarily want it to start cutting when it's arcing in on a corner. You want it to kind of lead in on a flat edge, so it has a greater place to go, rather than having to immediately change directions after starting the pierce. I hope that helps clarify that. Oh yeah, so I'm glad you don't have to design these by hand in Fusion anymore. Slicer is kind of a little bit of, it's been around for a while. Definitely be patient with it and with yourself. Thanks, Alice. I really appreciate it. And thanks so much for y'all for being here today. This was a really fun project. I hope it inspires you. Next week, we will have JD from Rainfall Projects on the stream. He is one of my favorite content creators and good friend. So he has a farm out here in Oregon and uses his plasma CNC. He's an absolute plasma CNC master. He also has a 5x10 router set up, and I highly recommend you go check out his channel. Some little homework before next week. And okay, one more question. Let's see, can you explain why the toolpath of just about any project seems to be so random? Text cutout will do the first letter and then the third and then the center of the O and then another letter. Okay, so you can tell different CAM programs to cut things in a certain order. You can say, oh, use the order in which I selected the vectors for you to cut. So you can try to dictate that. Otherwise, the program is just going to decide for you whatever it thinks is the most efficient. When you are cutting parts nested within other parts, it should cut the inside of a letter and then the outside later on. So for example, with the plasma CNC, there were circles within circles, like donuts within donuts within donuts. So if you think of a donut itself, it'll cut the inside of the donut hole and then the outside of the donut, because if you cut the outside, the part can move before you cut the inside detail of it. Yeah, so slicer is used for many different processes: laser cutting, CNC, 3D printing. So it's super versatile no matter what your process is. Okay, fourth axis demo in the future definitely can help arrange that for you. And okay, so why not simply left, right? You can, I think in Vcarve, dictate the order in which it cuts. You can kind of give it cutting rules as well. I'll investigate that some more. If you have any questions at any time, feel free to reach out to the customer experience team at support@avidcnc.com. If you use this project or this process in any of your projects, please feel free to tag us at avidcnc on Instagram. You'll find us on the other side. Thanks y'all for being here, and I'll see y'all next week. Okay.